By the end of this unit, you should be able to describe how to document data requirements to business challenges, explain best practices for gathering data, and explain some methods for handling confounds in data. Too often, data scientists will find themselves deep in the process of developing a solution based on the data that was provided to them before they realize that the data itself is flawed, inaccurate, or in some other way non-ideal. Developing the habit of creating a simple document with at least a description of the ideal data needed to test the hypotheses around the business problem may seem like an unnecessary step, but it has the potential to both streamline the modeling process and help ensure that all future data come in an improved form. The process of gathering data is often referred to as extract, transform, load, or ETL. Data is generally gathered from heterogeneous sources, cleaned or transformed, and loaded into a single place that facilitates analysis. Before the advent of the modern data scientist toolkit, data was often staged in a database, data lake, or data warehouse. Still today, data is frequently staged to facilitate collaboration, but there are tools now that enable more possibilities today than ever. Jupyter Lab has an extension called DataGrid that allows it to read delimited files with millions or even billions of rows. Tools such as Dask can help you scale your analysis with such massive data sources. To ensure that projects are completed in a reasonable amount of time, the initial pass at ETL should use a simple format, like CSV, then a more complex system can be built out once you've successfully built a minimally viable product or MVP. Plain text files can come in many forms, and generally the Python open function is used to bring the data into a Python environment. This is a flexible format, but because no structure is imposed, custom scripts are generally needed to parse these files, and these scripts do not always generalize to other plain text files. One of the most commonly encountered ways of storing structured data is in delimited files, where rows of tabular data are stored in lines of text, and the columns within each row are separated by a special delimiter character, such as a comma or a tab. This simple structure helps account for the popularity of these formats, with probably the most widely used being the comma-separated values, or CSV. The JavaScript object notation file format can accommodate quite complex data hierarchies. A JSON object can be thought of as analogous to a Python dictionary or list of dictionaries. Python's built-in library handles reading and writing JSON files. In addition, pandas.readJSON is also available for loading JSON files. Relational databases, such as IBM DB2, are those that impose a schema on datasets. They are a major source of data for data science projects. Database tables can naturally be converted into Python objects like pandas data frames. Reading data into a Python environment requires opening a connection to a database, and there are various libraries for managing this connection depending on the type of database to be accessed. NoSQL is a catch-all term referring to non-SQL or non-relational, or more recently, not only SQL databases. These databases use a method for housing data that does not impose a schema on those data. This trade-off gives you greater flexibility in what and how data are stored, but at the cost of increased traversal times when searching the database. When loading or dumping data between a file and a database, CSV files are a good match for tables in a relational database. JSON files are more aligned with NoSQL databases. One flexible and popular example of a NoSQL database is MongoDB. MongoDB has a client for querying it directly, as well as a connector for querying from within Python. The Python connector to MongoDB is called PyMongo. Automating the process of downloading content from websites is known as web scraping. Various tools in Python are available for accessing and parsing web page data. Beautiful Soup is a Python library that provides tools for walking through web page structures in a systematic and repeatable way. Beautiful Soup can be used to extract the relevant data from the soup of all of the other information contained in an HTML file. Another tool specifically designed for web scraping in Python is called Scrapy. Data streams are becoming more common. A data stream is a sequence of digitally encoded signals. Data can be streamed for many purposes, including storage and further processing, such as in modeling. Data streams become important when the data of a project or a company becomes mature and the AI pipeline is connected to it. As we move into the portions of the AI enterprise workflow that focus on models in production, we will be using Apache Spark's streaming to connect deployed models with streaming data. Apache Hadoop File Share, or HDFS, is the core of Apache Hadoop, an open source system that is designed to use arrays of commodity hardware to store and manage very large data sets. Apache Hadoop is a de facto standard in many large enterprises today. It is often used with Apache Spark and a NoSQL database engine to provide data storage and management of data pipelines used by machine learning models.